In this video, we're going to learn about a new kind of matrix, and then we're going to see how to compute their determinants. Here's our new kind of matrix. An upper triangular matrix is a square matrix where every entry below the main diagonal is 0. And I've drawn an example here along with a triangle. So these are 2 by 2 matrices. And notice the diagonal is here, 1 and 4. Below the diagonal, we have a 0, and above the diagonal, we have some other number, in this case, a 2. So the matrix makes this diagonal shape, where the shape is a triangle, and it's on the upper half of the matrix, or the upper right of the matrix. And that's where this name comes from, upper triangular. There's also something called a lower triangular matrix. I haven't written out the definition, but from this picture you can probably imagine what it is. A lower triangular matrix is a square matrix where every entry above the main diagonal is 0, like this one here. And then we get this triangular shape in the lower left of our matrix. Now let's see how to compute the determinant of an upper triangular matrix. Lower triangular matrices are similar. This one is a 4 by 4 matrix. Here's the main diagonal. And notice that everything below the main diagonal, these 6 entries, are all 0. So now I want to compute the determinant. I'm going to pick the first column because it contains 3 zeros and only 1 non-zero entry. So when we do its cofactor expansion, we have 2, or minus 2 times its cofactor. And we can see the cofactor by deleting the first column and the first row, and then recording what's left over. And then the cofactors corresponding to each of these entries don't play any role in the overall determinant because they're going to be multiplied by 0. Next, we have a 3 by 3 determinant to do. The first column, again, has 1 non-zero entry, and the rest are 0, so we'll use that for our cofactor expansion. We'll bring down our minus 2, and then the entry here is 1. We'll write that down as well. And then we find the cofactor by crossing off the first row and the first column, and then recording what's left over here. And at the end, we have a 2 by 2 determinant to compute. So we multiply diagonal entries and subtract. Notice that 5 is being multiplied by 0, so this doesn't play any role in the determinant. And at the bottom here, I've just written out what we get. Minus 2 times 1 times 2 times minus 3. So overall, the determinant is 12. And also, we should notice what numbers are in our product, because they're exactly the same numbers that showed up on the diagonal of our triangular matrix. The next theorem tells us that for any triangular matrix, whether it's an upper triangular or lower triangular matrix, the determinant of a triangular matrix is the product of its diagonal entries. So finding the determinant of a triangular matrix is one of the easiest kinds of determinants because we don't have to do any cofactor expansions. Just multiply what you find on the diagonal.